Kim asked me to talk about just basic motor operation. I don't really have an agenda because that's kind of a broad subject, so I didn't really know what to focus in on. So I think we'll just do basic stuff. So I think what I'd like to do is find out if anybody has any specific questions or concerns or problems on motor hookup or operation or anything like that, then we can just talk about that kind of stuff, and then I can try and illustrate some things, you know, up on the tab as we go. Anybody have anything specific or any problems? Or because Kim said that he was kind of, these are the things that he thought were needed just by looking on the forum and people's questions and things like that. So if nobody has anything specific, then I'll just start on basic stuff. Is that okay with everybody?
Yeah.
We're gonna get real basic because I'm basic.
And that's okay, because there's a variety of skill levels in here, so.
Right, and I understand that. That's the reason I asked what specific problems we were having, but nobody's having any problems apparently. So we'll just go from the beginning, from what I know of a beginning, from my beginning when I began to learn some things. And wasn't that long ago that I knew nothing. And I was working with Sidney Lamb for about 6 years, and Sidney has taught me just about everything. And then, of course, with winding motors and things like that, I began to learn some things, and then I find out how much I don't know. So it's not, I don't think I'll ever get to the point where I'm going to know everything. I'm probably not going to know half of what's out there to know, but
I have a
basically
question.
I'll start with,
If the motor doesn't work, where do you start?
Perfect. Where I start is continuity. That's when you've got these coils and you've got a beginning and an end of a coil of wire. You know, for this application, we're going to make 4 coils or 4 poles. And when these are connected together, and I guess I should have talked about that first, but anyway, when these are all connected together, let's say this is the beginning and this is the end. Actually, this would be the end. But when these are all connected together and you apply some current, like a lamp, to check, or even an ohm meter or something, then you should have continuity. In other words, electricity should be flowing all through these 4 coils. And that's where you start on your fan. You check you've got your 3 leads coming down, or 2 leads coming down, or 5 leads coming down, whatever you have. And then you should have continuity between them. Like I say, there's so many variations out there, so you won't have continuity in all of them sometimes together and with the 2 that you're testing, but there should be continuity throughout there. That means that you've got good contact in there and the coils are in good shape and current is flowing properly.
So how would you test that?
I check it with a lamp, you know, like a light bulb. What do we call those?
It's really no name for it. Just light bulb in series with the hot lead going to the motor.
Yeah, you got a light bulb here, and then you got a line 1, line 2. This light is in series with this line 1. Then you have your plug here. That's going backwards, but I'm not an artist. But anyway, you got your plug here, and then when you touch these 2 leads here, then this will light up. That'll tell you have continuity. Some people use just an ohm meter or something, you know, to check continuity. I just always use a lamp.
Sometimes you can also use a multimeter to test stuff too.
I'm sorry?
Sometimes you can also use a multimeter.
Yeah. Ohm meter, multimeter. Yeah. I guess Sydney showed me this, and I just like to see the light. That way I know. An ohm meter, sometimes I get some really, depending on the temperature and different things, I get different readings with ohm meters. So, I mean, I use it to check resistance, but that's about all I use an ohm meter for. I don't really use it for
So you feel this is more fail-safe?
I like it better. It's what I use. So anyway, continuity is where I start. And then whenever I have that, of course this is after I get something wound up, then what I check for next is polarity. And these same coils, say we have 4 of them, like we did on the other page, left to left, right to right. That's line 2, line 1, coming in. Yeah. Once you have your polarity, then you should have is that right?
North, south.
You should have an opposite polarity. In most of these motors that we work with, they're going to have this. Some of them, this is not so when you have parallel windings, but I'm not going to talk about that. This is just your basic hookup to where when you check your polarity, what I do is I use DC current,
It's a motor, it's a
low
motor, it's a
voltage
motor.
DC current, and I'll connect here and here, and at the beginning of the end. And then what I use, I have a little compass. It's in a little bubble. I got it on eBay. And what I'll do is I'll set it inside the stator when these coils are in there, and I'll go from coil to coil, and it should say north, south, north, south, north, south. That's not a good illustration of that. It's going to be something like. A stator, and you have the coils in there. Say this is a 4-pole motor, and these are 4 coils. And then I have you have your beginning and ending of each coil. And I usually start with the left, and I'll put my line 1 here on the left, and then it comes off on the right, connects to the right of the next one, and the left one will be next, and it connects to the left of the next one. And then you have the right, left, and it'll connect to the right here, and then the last one will be the left, and that'll come down, and that'll be our beginning and end. So, and that will give us, if these are connected properly, there's no breaks or whatever, then that will give us our opposite polarities.
So your line 1, line 2 is essentially your head wire in this illustration?
Yeah, this is your power. But I mean, you'll come off, like in a shaded pole motor, just a basic motor with no start windings. We have our little shady coils in there, and they're in here, and they set the direction of rotation, and that's which way the rotor will spin when you have all these correct. You have your continuity, you have your polarity. Theoretically, when you and this is, so we will have 2 wires coming off of a shaded pole motor. Then it should run.
What determines the polarity at each end of the coil, the way you wire it? From
Yeah.
coil to coil, where
Yeah.
you place the wire?
Yeah.
So if we don't wire, okay, that determines the polarity at each end of the coil. Reverse the wire over each coil.
Yeah. So that's called a consequent line.
No, that there's not consequence. Consequence is where you have them all hooked like directly in series, and that you would say, for example, you had a pole. I'll explain that.
No problem.
Say for example, we got a coil here and it's around like an iron core. And that's our iron core and it's being surrounded by this wire. And say we had another iron piece coming up right here. And if we wired all of these where our jumpers were just like from here to here, we're not, see where Rick has got it reversed on this coil? We're not going to do that. And what will happen is, with a consequence pole, if all of these are well north, we will get the south to appear there. Now the way this works, in this hookup, if you notice the wires are going around like this, and then they come back like this, the current is flowing the same direction from both coils being side by side like that. If we had this reversed, the two wires, current going this way and that way, would cancel each other out. So that's why we're reversing the polarity on every other coil in just a standard hookup. But the consequence, you would have like an extra piece of iron core here, and that would, consequently you would get that extra pulse. That would be an 8-pole motor with 4 coils.
Is that what you see in pancake motors, that little, the electric piece
No.
between the coils?
No, a good example of that, if you've ever seen like on some of the GE loop handles where there's one big donut and it just kind of goes around the 4 coils, that's kind of like almost like a consequence winding there, where they go around this one and that one, and these two here have nothing around them, and that's how you get that.
This is called what?
This, the consequence, you've got your standard hookup, then you got your consequence, and then the skein winding that I was just talking about.
Yeah, but I mean, this kind of wind is called what?
Consequence, where we got the extra pulse.
No, without.
Yours?
Yeah.
Just a standard winding.
Oh,
Yeah.
alright, yeah. Okay, so this is, thank you, Jill. This is a shaded pole motor. So there's no start windings, the shading's in there, and from what I've read in the motor winding books, when you power this up, when you have continuity, when you have correct polarity, you put power here, this becomes an electromagnet, and you can take a screwdriver and touch this, and it'll pull that screwdriver in. These shading, these little shading poles, or those little copper bars that are in those shaded pole motors, those are your shadings. And what that does, I guess, from what I can gather, is this shades those electromagnetic waves to where in between these coils, so when this rotor is in here, it will determine the direction of rotation, these shading, where they're positioned. And the thing about these shaded pole motors is you can literally take it, if you've got it wrong, you can take it and flip it around, put it back in there, and it'll turn the correct direction. The motor books that I read, they talk about these old motors where they had the stator, and then they had the 2 end plates and a rotor inside, and that's exactly what the book said. It says if you've got the wrong rotation, flip the ends around. So, very simple motor.
Bill, haven't you put a can or something in the stator on a pencil or something like that?
Yeah.
And it turns.
Yeah, you can do that.
Just like
Yeah, just get you a little can and put it on a string, and like I say, I always use DC current.
The shell from a fluorescent starter works real good. I wonder
Yep.
where I got that idea.
Yeah,
Just hang it on a string, it'll just spin like crazy.
yeah, sure can. I don't do it for very long, because I don't want, because this is gonna generate heat when you put electricity, so I just do it long enough to see the direction of my rotation, I stop.
Make sure it's right.
That's it. And I still make mistakes, I still put them in.
Well,
True story, I do that.
when I was working in electric motors, my motor tool supplier actually sold a tool which was nothing more than a fluorescent starter on a stick in a little plastic cylinder for checking direction.
Yeah, I bought some electronic ones, but they just don't really seem to work very good. I bought a few of them, 2 or 3 of them, and they just quit working. I don't know, it's just cheap Chinese stuff, so I guess. But I just still use a little compass, and then it's in a little ball, a little bubble with liquid in it, and I just hold it there every time. So,
And you wanna make sure you don't do it very long, because without the rotor in there, you have no core and there's not enough inductance to grow a lot of current.
Yeah, that's what I say, and with current you get heat, and these heat up pretty quick, these coils heat up, so I just, like I say, I just wanna see the direction of my rotation, and, that's it, so. Any questions? Okay, so, anybody else have anything at this point they wanna talk about? Any problems? Capacitor start motors? Okay, well, that's a whole different animal, that's gonna have your start windings in it, so I guess everybody's familiar with start windings. We'll go again with a 4-pole motor. And then these will be my regular coils. I guess I should write motor. I always use an M for motor and S for start. So, and we're going to put these start windings in here. 90 electrical degrees between the two mains. And so, what specifically did you want to know about capacitor run motors?
So they just connect directly. How do they connect in to the actual motor itself?
Oh, okay. Well, in addition to having this these connections between these motor windings, I'm going to come off with two wires that come off of the motor coils in series. Not in series. They're in series. They're in series. And then, so you're going to have a beginning for the motor windings, and you're going to have an ending. Okay? So that's going to bring us down to 2 of our taps coming out of the motor. Okay, now the third one is going to be the start windings. And so you're going to have a beginning of the start winding, and you're going to have an ending of the start winding. And these also will be connected in series to each other. And I also do the same thing. When I put in my motor windings, and then I check them for continuity, polarity. And then I put in my start windings, and I check those for continuity, polarity. And then I have my head wire. It's usually a 3-wire head wire. And then what we're going to do is we're going to connect the beginning of the start windings to one of these main windings, and that is going to become common. Okay? And then at the other one, I call main. I have common and I have main. The common is going to be the beginning. The main is going to be the end. Common is going to be the beginning of the main, beginning of the start. Main is going to be the end of the main windings. Now the end of the start windings, I call start. Now, depending on these type motors, the start windings and how you connect these, so this is going to make this rotor spin a certain direction when you connect it to the beginning of these main windings. It's going to, we'll just say for argument's sake, it's going to give me clockwise rotation at the blade side. Now if I were to put this over here, and this one, if I put this one here and put this one here, this would go the opposite direction. So the way that you connect your start windings to your common is going to determine the direction of your rotation. Now to confuse this further, I'm going to say this is when you need clockwise rotation with the head wire coming out the rear of the motor. Now, if you've got one that has the head wire exiting the front at 6 o'clock, you gotta flip these around. It's not gonna be the same. The hookup for a motor to turn clockwise with the head wire coming out the back versus the front is gonna be different connection on it. And you just have to test those. What I do is I wrap this around that motor winding, hook these up to my choke coil, and then use the can, to see my rotations. So, and then to answer your question, you have a capacitor that you want to put in there. And I always have to look at my cheat sheet, my capacitor cheat sheet, because I don't deal with capacitors that much. But I got a bill. Anyway, we have our motor here, we just talked about, with its 3 head wires, okay? We got common, main, and start, okay? Then we have our choke coil, and high, medium, low. And then we have our capacitor. Okay? So, what we're going to have, and then we have our, of course, we're going to have our line 1, line 2 coming in. Okay? So, help me out, because okay, so I know that the capacitor has to hook to the start and the main. Both of those are going to connect to the cap, right?
Yeah, the main and the start are gonna go to the cap,
Yeah.
and then common to line 2, line 1 to here, and then off of here, we're gonna go over to the main. Right
Yeah.
here.
Line 2 to here.
It doesn't matter, line 2, yeah, line 2 will go to the choke. And then we're gonna go over to the-
So the SMC it's a fan company as well. SMC. It's a fan company. It's a fan company.
So it's a little bit complicated, but basically your capacitor just increases your starting torque. Some of the capacitors are start run. Did you get it from down the hall here? I started to get their coffee, and they're going to hear about it. Nicely, but they're going to hear about it. Thanks, Kim.
Thank you, Kim.
A capacitor causes a phase shift to get you your starting.
Well, what I found in these capacitor run motors is that they have a lot of start windings. A lot of start windings. They like 2 to 3 times more than just a regular. And I never figured that out. Why would you put more start windings in a motor just to get it to run when you could use less and not even use a capacitor?
Starting choke as part of the sweep coil,
What?
as opposed to a starting choke.
They have both.
Well,
Like these later Emersons?
What the capacitor's good, if you got, the reason you gotta start a motor is you got a north, your main windings, you got a north, a south, or south. Well, you put the juice to it, and it sits there and goes, with AC, this was north, this was south, and they switch. And the motor just sits there and goes like this and buzzes. There's nothing to make it go. You put your start windings in there, and hook them up, you got the same problem. You got the main and the start. And the motor just sitting there buzzing. The capacitor causes a phase shift or a delay. That's next semester. So that you've got a north and then half a cycle later, you've got a north over here. And then your main winding takes over, then your start winding. So you cause a shift so that you get something to make it rotate.
Yeah.
And it can be either, it can be a capacitor, which causes a phase delay in one direction, or a coil that causes a phase. Does the same thing, but the opposite, goes the other direction. Just something to change the timing so that you get a rotational deal. Once the motor's up and started, the starting windings are still there, and your capacitor's still there, and you're just wasting the electricity.
What I read on capacitors, and I got the Electrical Motors for Dummies. That's the truth, I have that book, and I read that book. Capacitors, basically what it does is it lines up little negative charges, and it stacks them in here, and then it releases them at a certain point to increase your starting torque.
So, is it to aid or assist in starting the motor up? I was read it was for like energy efficiency.
They are very efficient motors. Yes, they are. Like the late model Emersons. You can go high, medium, and low and get all 3 speed changes, and you have very little increase or drop in amp draw.
Okay, so
I mean, it'll just be dead even all the way across the line on all high, medium, and low. You're going to be pulling the same amount of amperage, but you're still getting a speed change. Very efficient motors, yes, but my problem is, no, I'm sorry, go ahead. That's a big resistor. That resists your current flow, and that will give you your speed change in your motor. Because if you just have power coming to this motor, it's just going to run at one speed. What this does is kind of goes through this choke coil and it slows it down. In other words, it takes that current has to go through those windings before it comes out here as medium to give you a speed change, because it's gone through all that resistance. And the Dummies book talks about water through a garden hose. It's the same concept. If you take a 1-inch garden hose and you put water through it, and then it drops down to 3/4 of an inch, you know, you've increased your pressure. Was that right?
Yeah.
Okay, and so this is basically, your choke coil is just a big resistor. Well, not a big one, but enough to affect a change up here in what we're looking for. So, I don't know, capacitor run motors, I mean, they're there. I don't really deal with them that much, and when I do, all I do is change the capacitor out and put a new one in and throw the other one out. And go, but I do like the way they run, but I don't
Can I
like to
tell you
wind
about
them
like
because
blown
there's just
capacitors a little bit too?
a lot of start windings, and I just see it as a waste.
Like,
Because I can drop with just a standard
I don't know.
wind on an Emerson motor, I mean, you get a really efficient motor. I mean, you can run them at, you know, the 12-inch fans, you can run them at, right around an amp. I mean, that's okay, you know, an amp or under, or right at an amp, and they're fine. Of course, the capacitor run, you can run less than an amp, pretty good bit less than an amp, but, I mean, you're talking about an amp. I mean, my coffee pot draws 4 amps, you know? Did you have a question?
Well, because capacitors, once they're blown, they're dead. I mean, sometimes, like if you use, like for example, if, like, I have a Hubbard Builder's Best has a blown capacitor, and, like, if it's running, like, if it only has running, like, a high speed, and it's kind of like a low speed, and then one speed, it's, like, off, and low is, like, off, and then off. So, once, like, the reason why it does that is because if you go inside your switch housing, you have a blown capacitor, sometimes you may have to go to your local hardware store or whatever, or replace a capacitor.
Yeah.
Yeah.
I mean, capacitors are either good or they're bad. There's really no in between, I don't think. You ever found one that's in between, Bill? Bill went to sleep. Anyway, what I'll do is I'll talk more about a choke coil. And the way I do this is, like say for an Emerson start, most of them start low, medium, and high. GEs and Westinghouse and all that, they start high, medium, and low. So I'll start here with an Emerson, and what we'll do is we'll say the top of the, well, this will be low. And when I wind them, I start off on the low tap. And what I do is I put in so many turns, and then I'll have a center tap, and then I'll put in so many turns, have another tap, and I'll put in so many turns, and then I'll have the top. And those are in here, in the little, you know,
This is the choke coil, right?
Yeah, this is a choke cord. Low, medium, and high. And so basically that's what this is. And then so they're all wound in here, and I didn't bring anything to illustrate how I do it or the winding or anything, but that's essentially it. You've got 4 taps, and this low will go here. This medium will go here. This high will go here. And this top comes out the back.
So when you wind that choke coil, kind of dictates what speed that fan's gonna run at each speed to some extent.
Yeah. And historically, Emerson, really all of them, they didn't really do that good a job. The way Sydney explained it to me is, back in the day before air conditioning, they wanted them to roar. They wanted them to go fast. So they put something in there just to put in there, you know? You got very little difference in speeds. Sydney and Tom Newcity, Tom's done a lot of experimenting with these, especially the 29646s, some of the other Emersons, and he's come up with this, what I call the Newcity formula, or the Tom formula, and he's moved these numbers around, you know, and added to and subtracted from in between these to get a more optimal speed change in there. And he's pretty good. Tom's very good. And so we've got some of that we do too. I've kind of gotten away from that. I was doing quite a bit of that, but then I've got so many customers that say, hey, I don't like that. That's not the way. I was like, all right. So I just started pulling them out and counting them, and whatever I take out, I'm gonna put it back in. Because then I have to convince them that, you know, hey, this is different, this is better. And they're like, well, you know, I don't like better. I don't like different. You know, I want what they had. And I said, so, but anyway, that's a possibility too. So just to give you a number, I'd say like 105, 80, and 300, or 250 to 300. Maybe came in something like that. And so you can move this number over, and you can increase this to say 100. Okay.
When you talk about
The number of, yes, I'm sorry, the number of turns.
changing of resistance.
Yeah, I'm moving these numbers over, you know, so in other words, this one, instead of having 80 turns in here, we'll have 100 turns, and this might go down to 200. Okay? Might leave that one the same, might add 25, I don't know, 150. I mean, really, a few turns here and there really doesn't make a big difference. So, there's a lot of experimentation and a lot of things you can do, a lot of ways you can go. You can increase your wire size, you can decrease your wire size. You know, so that's
So a lot of people in the club complain about there's no speed. A lot of these fans don't have much speed difference. In
Yeah.
a lot of the manufacturers across the board. So that makes sense. The manufacturers didn't really care. It was just for, they probably wanted to blow and go, so they ignored the coils in between. Stop and
they
go.
put something in there, yeah.
I mean, because these people were using these fans to try to get cool. So
Yeah, this was it. This is what they
They
had.
didn't care about low.
Right, right.
Just blow and go to try to get cool.
I could ask him about like intelligence fans and stuff.
Even though it doesn't really have, and also with 120 volts, 125 volts, you could vary that and bring it down to 110, 140.
Okay, I'll ask him. Maybe we should have brought that.
We don't have these saturation before.
Yeah, Rod just covered it with the, like if you look on your really old fans, a lot of them are 104 volt.
Right.
And a lot of the fans from the 30s and that they serve 110 volt. And what are we running? We're on 120, 125 somewhere. That extra 15 volts is causing your low speeds to ramp way up. With the Variac, given what they're rated and built for, they're going to slow down.
Okay, one thing I wanted to talk about personally is, did that answer your about the capacitors? Okay. Is the hookup Okay, we've got high, medium, and low. High, medium, and low. Okay, we got my line 1, line 2. Got my 3 wires coming out of my motor. Now, I'm not trying to insult anybody's intelligence, but I've done this, so I know what'll happen. Never connect line 1 and line 2 to the same piece. Don't ever put a line 1 and line 2 to your choke. Don't ever put a line 1 and line 2 to your motor, because that creates a solder joint. Whatever you have connected, it's gonna cook, and I've cooked them, baby. So trust me, I have. So, what we have here is line 1 usually goes, we'll just say to the main winding. I use red, okay, main, and that'll be connected there to a post, usually on the back up here, somewhere on the choke coil base. You'll have a line 1, and the motor windings connect to that. Your common usually connects to the top of the choke coil right here. And then the start windings usually connect to the high side. Well, I guess this is a GE because I got the high over here. So, a lot of fans hook up that way. On an Emerson, this would be over here to the far right on most Emersons. I think, aren't there a few Emersons out there that actually started on high? Or was that just that they had the numbering different?
The 11646, those start on that.
They do? Okay. But for the most part, this is a hookup. Like I say, just the another line will go in here on the switch base. Did anybody notice we didn't get any coffee this morning?
I did.
I'm mad.
Now you got plenty.
Yeah.
Someone told me they don't start the service till tomorrow, in the room, I don't know.
That's what
They got it down the hall here. Well, anyway, that's the big joke on me. So I just wouldn't let go of it.
So there's probably about 6 more cups on the way.
Yeah. Does anybody want coffee? Because I'm not gonna.
No, thank you. I'm not want coffee anyway.
But does anybody get this? I mean, you all understand this. Don't ever hook line 1 and line 2 to your choke coil. It's gonna work.
I don't even remember, we're talking about line 1.
You got 2 prongs, or 2 wires coming from the wall.
It's just your hot cold from this, your circle, hot juice.
Yeah, call them lines.
It's like taking 2 wires and just got a lot of this.
That's exactly what you're gonna have here. I've done it. I mean, they make a hot fire too. That motor just does not stop cooking. It's too late. Even if you stop it right then, I mean, it's still gonna cook. I mean, it's like wow. I mean, if you want to show, just want to do something for fun, but just make sure you do it outside, because man, it is gonna stink the room. So just be real about that. Don't ever connect line 1 and line 2 to either both of them to the motor or both of them to the choke. That's a big number. Yes, sir.
A safety device would be to put a light bulb in series with line.
That's what Bill said,
line
yeah.
2. If you're uncertain, it's a really good idea. It's
Yeah.
a lot better to have that light up bright than to destroy something.
You're right. Yes, sir. That's what Bill was telling me yesterday. Yeah. I don't have that. Sydney didn't have it. I don't know about it. Yeah, good idea. Anybody have anything else? Any questions?
But the high is bypassed.
Oh.
The choke doesn't use the choke. It goes right to the motor. Right?
Most of the time, yeah.
Yeah, so you can check it. You can put.
Actually, no. On Emerson, there are like.
I mean, like the GE.
Yeah, but yeah, you're right.
You know, the to bypass and show it'll be on high.
Right, basically, you're right, yeah. Yeah, there is a tap coming from here, but there are no turns in between
Right.
here.
Right.
Yeah, you're right. Mhm.
What are the three wires coming off the motor you have left?
Your start windings, your motor windings, and your common. On a 3-wire motor. Anybody have anything else? Any questions?
I had a 10-pole test with 133 cycle, and I changed that to 60 cycle. I rewired the coil.
A 10-pole Tesla?
133 cycle.
I've had one experience with a 133, and Bill has worked on it too. We never got that motor going.
Well, with the 133, you can buy yourself an inverter, and they're getting quite cheap now. And I bought one for about $100, and it will give you the 133 cycle.
We recommend one to
Probably VFD, variable frequency drive.
and there's we use those on our.
And you can dial in whatever frequency you want. I have 25 cycle fans, and I have 133 cycle fans. I run them both.
That's the easiest way to do it.
Yep.
Yeah, there's a lot of variations on these motors out there. Just so many of them that way more than you think, way more than I ever thought. And to be confident and proficient in all of them, it's a struggle. For me, anyway. I mean, Bill's got it nailed. He's done it all his life. I mean, in terms of getting them rewound. In terms of maintaining them, if they already run, there's no problem, right?
When you rewind them, say you got a burnt, when it's burnt, you can't count the windings. You have a chart for how many windings on this particular stator?
No,
No?
no. What I've been doing is I've been throwing them in, I used to just cook them. I put them on a fish fryer and a little propane and I cook them. And then I started, like on the choke coils, because it would burn the wires and I couldn't count them accurately, I just drop them in some carburetor cleaner for a couple of days and then you just unwind them. You
Some
can do the
of
same
them
thing.
are broke, some of the
Yeah,
wires are
yeah,
broke.
some of them are, but not all of them are. You can take and you have to count the number of turns in each pole.
I thought there was a standard.
No,
from the
like I said-
From the factory, standard amount of windings per.
There's so many different sizes, types,
Yeah.
variations. I mean, if there is one, I don't know about it. You just have to, that's the way I was taught, you have to pull them out. And that's what the motor books tell you too, if you read those motor books. Take them out, count them, measure the wire, and then put them back in the same way with the same pitch. Yes.
I wonder if either of you or anybody in the room has ever seen an open, burned, or shorted rotor.
Open rotors I've run into mostly on Westinghouse pancakes and Teslas. But yeah, if you look at a rotor, there are like copper bars going through the rotor, and then there's a ring around the outside where they're all soldered on. And usually those solder joints go bad on those. You gotta go around with a torch and a soldering iron and just solder them all up.
Just connect them all back together.
Yep.
So one of the things that people are doing is they're polishing those out, they're moving it.
You don't wanna do that.
Not a good thing.
That's right. Leave that alone.
Any thoughts if you do that to the solder, any way to make it look old?
Get the solder.
There's no electricity.
You have to call Steve
There is.
Yep.
It's a transformer. You got your magnetic field coming from your stator, and those bars make a one-turn secondary each pair. And the current is horrendous. The reason those bars are almost a quarter-inch in diameter, there's hundreds of amps going through that rotor, that's why they get hot. And those solder joints, in fact, Bill and I were working on one down at Dunaway's. It didn't want to run right, we cleaned it all up, resoldered all those joints, and ran beautiful. But there's a horrendous amount of current going through those bars in that rotor.
Yeah, I've seen Bill and them working on mini rotors up at docks, heating it up, resoldering them. I personally never have. Guess I've never run across a bad one, but Yeah, I've watched
It's
them do
pretty
it.
rare, is it, to have a bad rotor, unless someone's sanded or monkey with it?
It's rare.
No?
It's rare. But if you buy a fan and you have a 4-pole motor, and you notice that the motor wants to stop 90 degrees apart, and you move the blades a little bit to the right, and it jumps back. Move it a little bit to the left, and it jumps right back to that same spot. And then you move the blade about ahead, maybe 45 degrees, and then it wants to go. Those are signs of a bad rotor. And another thing you can do to check for a bad rotor is if you hook up an amp meter to your motor and spin the blade slowly, and you see your amp meter going up and down, it doesn't stay constant. That's an indicator of a bad rotor as well. And I'm going to demonstrate tomorrow how to check a rotor on a Growler.
Good.
I've got a question. This discussion about rotors, are you speaking of AC rotors?
Yes.
Yeah. On a DC motor is called a armature. Yes. And they have windings. They have windings in them. Yeah. Of course, some of your AC motors have them.
Everything's just different, there's always exceptions to the rule.
Yeah, that's what I'm saying. There's so many varieties and variations and sizes and types, and it seems infinite to me.
Yeah.
Let's see, what else can we talk about?
Question.
Yeah, when you start talking about DC motors, sometimes the armature and the field coil are in series and sometimes they're parallel. What are the thoughts about why they can be?
I don't know. I've never worked on one like that. Usually the ones that I have coils that are in parallel are usually a shaded pole motor. Not
I'm
one
talking about
with
DC commutator.
Oh, commutator. Yeah, I know. Yeah, I know what you're saying. But like I say, I've never worked on one that's been wound parallel with a DC motor.
You find that more in industrial motors. That's a shunt wound motor, and you're not going to find that in a fan.
Yeah, I don't have the
You
experience.
look at the early catalogs and they'll say this is a shunt wound motor or this is a series wound motor. and stuff.
Yeah, I've read about the shunt and all that stuff. Yeah, I've read about a lot of that stuff. Most of the DC experience I have is just rewinding the coils like they were, putting them back in the same way, and going with it. I don't know about a parallel hookup on with an armature. Never had any of that. Anybody else? Any questions? Any thoughts?
Why did
Suggestions?
they make the spin start motors into early fans? They couldn't get going, that is without the help.
Because they hadn't invented start windings yet. You were the start.
Yeah.
Yeah.
I know Doc has one like that.
Patent protections, I think.
I don't know about that. But I mean, we have a lot of those today. People have a lot of those today. They text me and they say, my fan runs when I spin start.
What is that, bad start one?
Start one, usually. For the most part, but there is I found there is an exception, and that has to do with the centrifugal switch pieces in there. And there is a certain type out there, I think it's a GE, that has a ceramic mail-in on the that goes into the rotor, and apparently the two little brass strips wear down and they won't contact. But when you test it, it's symptomatic of bad start windings. But you put in all new windings and the thing still does the same thing. It's like, really? How does this? And that's what it is. It's that bad little male end of the centrifugal start mechanism. And I've got one for Jeff Dunaway. Same thing. I think. I don't know, because I don't have another one to replace it with.
I got a first variant BMY, that 1908. It's got the centrifugal start switch.
Yeah. I want
The fan will, 8 or 9 times out of 10, you turn it on, it starts right up. That last time, you just touch the blade. I mean, barely
Yeah,
move it.
yes.
It keeps right on.
Yeah. And 99 times it's gonna be start windings, but that one time it's gonna be that little male end that's bad, and I
think
don't
it's
know
just
how.
wore out a little bit.
You can put a relay in there, but people don't want a relay, they
There's
don't.
little flaky fingers in there too, that if they get skewed a little bit, then they don't both make contact. Or if there's somehow, if something's off center and they move a little, and they're also kind of spring loaded in a weird way so that they don't always.
That's
it's a
what,
bad design.
got the same thing, he's got that issue too. He's got that bad one, that bad little thing I hate, Sydney hates them. He always puts relays in his, and, then those, yeah.
And you can have bad springs too. Some of them, you can get to a point where the current actually ends up going through the spring, turning it into a toaster element. Not a good spring.
Makes good toast,
Well, little pieces.
Yeah. Yep, so, yeah, start winding issue, most of the 99% of the time, yep.
Do you ever rewind just to start windings, or is it just
No.
easier to do the whole thing?
No, sir.
I don't think you can get them out without.
Some people do, there are people out there, I mean, Bill digs in those motors and he finds the brakes and 2 or 3, 4, 5 different brakes, and then,
Just rewind your start one.
yeah,
So
yeah.
I think you can get them out past the main stand.
Pete Hahn, he's crazy. I've wound, he's told me, just send me some start winding. Jeff Whitfield, have you done that too? Jeff Whitfield's done that, he's pulled out start. I'm not gonna do it because it's gonna take me 3 or 4 hours and I'm gonna break something. I'm gonna end up rewinding the whole motor for free anyway, so I'm just gonna say no. I'm not gonna do that, I'm gonna just wind the whole thing. That's just me. But there are people out there that do it. Pete Hahn, Jeff Whitfield, fine. I'm glad you do that.
It all depends on how thick the varnish is. When they wind a stator, it's dipped in varnish. And some aren't varnished very good. You know, you can get the coils out and replace like one coil. And I've done it to an Emerson once. Most Emersons you can't get the starting winding out without destroying stuff. I did put a starting winding alone in a big motor yoke once, and that one was pretty easy to get out. But a lot of it has to do with the varnish that it was dipped in. You know, if it was a really good, strong varnish, you're not getting them out. But what you can do, you can put power to the stator and get it hot just by running power through your main winding alone to heat it up. So once that's hot, it's easier to get a starting winding out. Or to, you know, if you want to dig into a coil to find an open, you can heat up that coil. You know, heat up a coil that's good, or basically take that stator, put it in an oven for a while. Because when they're hot, the varnish will come apart better.
Did you use DC current or AC?
Just throw AC at them with like variac, kind of limit the current a little bit and warm it up.
To like what, 50, 80?
They're all depends on the motor. They're all different.
Oh, you just check it and find out what works.
Yeah, just what works. But I'm thinking 75 volts is probably roughly what I'm throwing through them to warm them up.
Yeah. Yeah. But no, I don't. And I don't replace head wires. Sydney told me not to do that because I'm going to get in there and I'm going to break something and then I'm going to wind the motor for free. So don't do it.
That's been on head wires where they got those, they're soldered, you got your little fine wire coming up, wrapped around and all that. Do not try to unsolder that, unwind it. Cut it off and tack on a new wire. Because if you sit there and try to unwind and unsolder that, your chances go up 25 volts of breaking the wire.
Yeah, speaking of soldering.
Leave you a nice little cut of solder too.
Yeah, speaking of soldering, Tom Newcity taught me this, and I'm sure everybody knows about it. I'll just mention it here. They got your 2 wires here that you're going to solder. And what you do is you get your bare wire. I should have made more space in here. I don't know why I didn't. Anyway, you put these 2 together. And then you go around it with a piece of magnet wire or something. Just wrap it around there. Well, he said to first create a good mechanical bond, and then you can solder it. And what I do is I've got these little hemostats that you get at the hospital, and I'll just clip them in there and it'll hold them while I get my wire wrapped around there. When I get my wire, then I can take the hemostats off, finish winding it, and then I make my solder joint. Of course, don't forget to put your shrink wrap on there first. Done that too.
What kind of wire did you say you wrapped that?
Magnet wire, just some of the same kind of motor wire that I use. You have to strip the insulation off of it and bare it, and then just wrap it on there. Good and tight, solder it, slide that on there.
You know what, the solder runs down in those wraps, makes a really good, like it says, mechanical bond.
Yeah.
Yeah, I think anything that would take solder would be fun. You know, solder running down those wraps this way instead of.
No matter how you solder those together, the main thing is to get them clean.
Yes. Yes.
Because if they're not clean, you're gonna.
Yeah, I don't know if you're soldering old to old. I don't usually solder old to old, but I have. Yeah, you got to get that old wire really, really clean. Yeah.
Tell you a trick for doing that. Get yourself a fingernail cutter. Take out the little lever and the little pin going through it. Now you got a tool where you just stick your wire in there, squeeze down on the fingernail cutter, and it will scrape just about any corrosion or varnish or whatever you got on that wire off. Makes it nice and clean to solder to.
Yeah, I've seen those. That's pretty cool.
Could you chemically strip it with acetone or something? No?
I just use a little butane flame thing, and I just heat it, and then it melts it. They're not too long, not for very long, because the thinner the wire, the more it's apt to just burn up, and you know, it'll get shorter. So, and then I will hit it with some steel wool, or a little brass brush or something, and spray it with some electrical contact cleaner. I use a lot of electrical contact cleaner spray, and it dries real quick, and you can clean them that way. Then I use flux, a little bit of that paste, and then basically what I'm doing is I put some of that little paste on here, and then I hit it with my soldering gun, and then by the time that flux melts away, burns away, then it's ready. And all you gotta do is touch the solder, and it just flows.
How much insulation do you strip off in that kind of connection?
You know, just whatever it takes, whatever you're comfortable with, you know, to make it happen. You know, I guess as you get more proficient at it, you know, it's going to be theoretically shorter. You might have to start off when you first learn it, you know, with a couple 2-3 inches. No, I'm just kidding. I don't know, a 1/4 inch or so, 1/8 inch, 1/4 inch, 3/16, 1/4 inch, 3/8. Yes, sir.
When you're putting coils back into the stator, are you lining them separately, putting them back in and connecting, or are you lining them as one long continuous? Just flip.
Yeah, I wind a skein, usually a skein wind I wind, unless it's like a pancake where they have separate coils.
Right.
But no, I wind skein wind.
Just flip it.
Uh-huh. Yeah. And that's another area that I'm not even going to get into is those polyphase wound motors. i.e. Rick Hill's BMYs, R&Ms, lots of GEs and R&Ms. And now the guy in Vietnam, he knows how to do a proper hookup, but my experience with that, with these guys here, even around here, this guy in California, can't call his name right now, Tim Marks, they both wound them, rewound them polyphase. I rewound one polyphase, one. I won't ever do it again. There's a lot of connections in there, a lot of solder connections. It just seems, and it seems like it's a very inefficient motor to me. You've got all that resistance wire in them. It just creates heat. That's all that resistance wire is. It's just, Rod said it talks like a toaster. I mean, I can't see how the thing just doesn't cook apart initially. I mean, I don't know how they ran for so long. And it's just resistance is all it is. It's just increased resistance. And how in the world does increased resistance make the thing go? But everybody that's rewound them here that I'm aware of has had to get them started with a capacitor. They didn't use a capacitor from the factory.
Resistance wire is cheaper.
But how does that make it start?
Well, so your capacitor basically lowers the current when you start winding. You don't need as much there. So the resistance wire does the same thing. You know, capacitors weren't that prevalent back then. That was kind of
That's what I'm saying. If we were to rewind one like that today, we would need a capacitor.
Or you could use a resistor. You just want to lower, in that case, you want to lower the current there.
Anyway, the one that I wound, I had something wrong in it. It was pulling like over 2 amps. So I had something wrong in there. I abandoned it. Never tried it again. I don't think, like I say, I think Tim Marks got his going with a capacitor. And the guy in California, I cannot call his name right now, but his, I think, I lost track of him on the forum, but I don't think his came out. And he did a lot of research, and he used a lot of different resistance wires, and he did a very thorough job in researching the whole project and tried several things, and I don't think he came out with a favorable, or I mean, I guess it works for him, but not what the factory did. He was not able to duplicate that. Oh, this guy, what's this guy's name in Vietnam? Dan. I think he can do it because he does the ceiling fans, and they have the same kind of connection. And he's diagrammed it on the forum before. I can't follow that. I can't follow his diagram. It changes colors and changes too much. I would need to explain to him. Do you understand those polyphase, Bill?
Yeah.
Do you? I cannot. What?
Desk fan, polyphase?
Yeah, that's what we're talking about. All these RMMs and these GEs and stuff, yeah, they're polyphase. Polyphase, or a lot of people call it basket weave. It's a beautiful weave. It's a beautiful winding when it's done. But it's very difficult to put in, very time consuming. And like I say, you got like 7 for a 4-pole motor, you got like 70 solder joints. You got to keep all those straight. The only way I can do that is to have 3 different size wires with 3 different colored wires, keep it all straight. Because I mean, you've got all these wires coming at you, and it's like, what? So, or you got to label them with tape. It's crazy. But I would like to learn it. Someday I would like to learn it and find out just exactly. I've read the books. I've read the motor books. I can do the hookup. I mean, I can see the star connection, what they call it, or a delta connection. I can read it all day long unless I have somebody to illustrate it and show me. I can't get it.
Thank you.
Anything else? Anybody have any other questions? Anything you want to talk about? Anybody find the fan that they came looking for?
Not too many.
Same for me.
Thank you.
All right, if you haven't found it, see Chad Baker. Thank you all for coming. Thanks to Bill and everybody else that helped out. I appreciate it.
Thanks for watching about the seminar, and I hope you enjoy it. Stay tuned for more to come. Bye.